All right, we're back again. Let's take a look at our lesson for today. We are focusing on distance, rate, and time and trying to check out the relationship. For some of you that remember your science physics unit, this is a review, another example of how math and science start to overlap more and more as you get further on in school. And the first problem that we're going to be looking at today is about a person named Axel. Axel is getting his pig ready for the pig races at a county fair. During the race, 4 juvenile pigs run along a straight track, trying to be the first pig to get to a cream-filled chocolate cookie. Axel's pig Hammy can run at a rate of 11 feet per second, and that is an important piece of information for us. As we take a look at the lesson in front of us on the screen, we have several things that we are going to do with this information. If Axel and his pig get going at the beginning of the race and he is timed for 3 seconds, we can figure out using this 11 feet per second how far Hammy can run. Most of us know that 3 seconds would be 3 times 11, and that would be 33 feet. If we check it out and see how far Hammy has gone in 5 seconds, thinking that this is his constant rate of change or his constant speed, 5 times 11 gives me 55 feet. And then we have 60 seconds, which is a little tougher, but if we cover up the 0 and we do 6 times 11, we get 66. And we put that 0 at the end and we have 660 feet. All right, let's take a look and see what our expectations are next. They are asking us to come up with an expression. An expression is something that does not have an equal sign. And we're going to go back up here to our underlined piece of information, 11 feet per second. That would be, we could write that something like 11 times x, which could be our variable, or because when we're writing this in our future math classes, we want to write this most efficient way possible, we could write it 11x. Remembering that when I have a number and there is nothing between that number and a letter, that means multiply. Moving on with our problem, the racetrack is 150 feet long. A diagram of that straight racetrack could look like this. There's 11. And I'm trying to get these as accurate and close to the same length as possible. Let's see what we have so far. 22, 33, skip counting by my 11s. Okay. Then we must have 110, 121, 132, 143, and plus 11, plus 11, plus 11. And then we have 165. Right. An equation for this could be 11x equals 150. Now I know that I went a little bit above that, but I was having so much fun with my 11s. And in order to solve this, we could rewrite it down here, 11x equals 150. And those problems that we've been doing in the past where we divide to get the variable by itself are what we would be doing now. And I did not bring my calculator down with me, so let's take a look at 150 divided by 11 goes in there 1 time, so this would be, and 11 goes into 40 3 times, 33, and then we would have 7 come out of that subtraction, bringing down the 0, and we would be able to do this probably pretty far and indefinitely. I think we're going to end up with a repeating decimal there. So I could say that Hammy will finish the race between 13 and 14 seconds.